Right, hello everybody. So it's time for a little project. Today, hopefully, I'm going to show you how to build your own dual coil immersion chiller. I've never done this before and I'm kind of making it up a little bit off the top of my head how I'm going to do it. So let's find out if it's a great success or if it's going to go totally tits up. We'll see. Okay, so what I'm trying to do is basically improve on the standard kind of immersion chiller that I've got at the moment, which I've got as part of my sort of starter set when I first did all grain brewing. It works, there's nothing wrong with it, it just takes quite a while to chill stuff down, and you do have to keep the wort moving over the coils to make it cool down at any sort of decent speed. So I've been looking at some of the American made models, like the what they call the Hydra, and there's another one, I can't remember the name of it, but the ones that are just shown on the Brewlosophy experiments quite a lot, which basically have lots of different coils on them, so they've got multiple kind of feeds and a whole load more copper basically than what we've got there. So the idea being that the greater the surface area of copper that's in contact with the hot liquid, the more efficient the heat exchange will be. Had a look at those online, massively expensive, way out of my budget, so I thought I'd try and knock up something that was along the same lines, maybe not as quite as full on as those versions, and basically step up from what I've got there to a 2-coil chiller, which will hopefully make it work a little bit more quickly. So, as I said, I'm not following a kind of existing design or anything, I'm sort of making this up off the top of my head. I bought all of the parts from Screwfix. You can probably get them cheaper from maybe plumbers merchants or something like that, but it was easy to order them online from there and do click and collect and everything. And just a couple of bits from B&Q, so just the hose adapters for B&Q, so they're only like £1 each. I've got 2 10-metre coils of 8mm copper pipe. I've got the 2 hose adapters, and then I've already screwed the coupling into there. I've got a couple of 8mm to 15mm compression couplings like that you can see in there, and I've got 2 8mm equal T compression fittings like this. That came in about 45 quid in total for the parts. Tools wise, I've got a pipe cutter that I already had. You don't have to have one of these, you could just use a hacksaw. I did buy a spring bending pipe bender as well online, so that will help me to put some of the bends into the copper pipe. Then you just need something to wrap around, so I'm going to use this pot here. It's just about the size of a paint pot, so a paint pot would do a good job as well. And that's it really. So yeah, let me show you how I'm going to try and do this, and we'll see if it works as well at the end, hopefully. So I'll test it out at the end and see if it does actually speed the process up. As I said, kind of came up with the idea of how to do this myself. I'm using kind of compression couplers, so I don't have to do any welding or soldering of pipes, because I basically don't have the kit to do that anyway, and I didn't really want to spend the extra money on it that I would need to do that. So if you are able to do that sort of thing, then there's probably better ways of doing this, or maybe cheaper ways of doing this, but I wanted to keep it simple so that people who don't really want to be messing around with blow torches and flux and all that sort of stuff would be able to do it just with the parts they can buy. So that's why I'm using the compression couplings, which are a bit more expensive than the solder joints, but as I said, if you balance it out with the cost of buying tools and equipment that you might only use once, it's still kind of cheap doing it this way. Right, yeah, let's stop blabbing on about that. The only other thing I wanted to say about the three-way compression couplings, I did want to actually go from a 15mm into two 8mm, but I couldn't find anywhere that actually sold any T-pieces that allowed you to do that. So it always seems to be one small fitting up to two larger fittings on the ones that are adapters. So again, if you are soldering stuff, you can probably cobble together something that does that sort of job for you easier, but with these I had to go with this. So hopefully it won't affect the flow rate of the water too much, but that's one potential pitfall for the idea that I've kind of come up with. So let's see how we get on. Right, first thing I want to do is basically cut off a length off of each coil, which I'm going to use for the pipe going down to the immersion chiller that's going to join onto the equal T and basically then do the outlet and the inlet. So we need to straighten out a length of pipe. This will depend on the size of your pot and how tall you want to make your chiller. Just be really careful when you're bending the pipe. And I basically want to get two straightish lengths of pipe off of each one. In this case, for me, about 45 centimeters long. And I'll use the pipe cutter to cut those off. Okay, so now I've got my inlet and outlet pipes cut off of each one. I need to start creating my first coil, which is going to go round this tub here, and once we get down to the bottom we need to bring the pipe back up. So the idea is that I'm going to have a T-piece for the inlet, which feeds coil one off of one side, and then the second coil off of the other side, and then the other T-piece will be the outlet. So yeah, let's do that now. So there we have the first coil done. Looks quite neat, if I do say so myself. A thought struck me while I was doing this, because I was going to leave enough at the end there for the pipe to come back up through the middle to feed the inlet or outlet even at the top. But I then thought, if the objective is to get the wort or hot liquid to flow over the coils as efficiently as possible, is an upright coil like this the best way to do that? Or would it actually, bearing in mind that a lot of us will be either stirring the pot in order to get the wort to do a whirlpool or using a whirlpool pump to do so, would it not be more efficient to have the chiller sat horizontally like this on the bottom of the pot? I think it will work better this way, so I'm going to do a last minute change of the design. So what I'll do now is put that back onto the guide, and I'm going to wrap the other coil of copper pipe around this in the opposite direction to give us our second coil. So there we have the second coil around the outside. That's again worked out quite well. I've consulted with a scientist friend of mine, Chris, known to some of you as El Chemist, and he has basically said that putting it on its side is a good idea, and he's also helped me out with a couple of other suggestions for potentially increasing the efficiency. So having the outlet and inlet at different ends, and the other thing is, as it's going to be on its side, trying to minimize any contact with the base of the pot, and also raising it up slightly so you get better flow underneath as well. And to do that, I'm basically just going to bend the final coil on each end out a little bit to kind of create a little, almost like a little stand for it to sit on the bottom of the pot when it's in there. So yeah, I will do that, and then I'm going to attach my T-pieces at either end, so we'll have the coolant water flowing in at one end and then coming back out the other end through the two pipes. Okay, so I've used my pipe bending spring there to, as you can see, just bend that outer loop out a little bit. So the idea being that it will sit on one of those at each end, in theory. So now I just have to try and get that same sort of shape into the other side. Okay, so when you're trying to use one of these, don't try and put more than one bend in at the same time, because that makes it pretty difficult to get the spring off. But once I worked that out, I managed to bend in a kind of little stand at either end, so it will now sit on those, and it gives it a bit of clearance underneath the coils and raises the whole thing off of the what will be the base of my kettle. So now I just need to try and get these, so I'm going to have to cut off a little bit of the excess coil on here. These two are pretty close already for me to fit the T-pieces on either end, and then we're good to go. Okay, so I'm going to fit the first T-piece on to this end. If you're finding it difficult getting the olive from the compression joint on, I find that if you use the pipe cutter and just cut off a small amount off the end, it squeezes the ends of the pipe in a little bit and makes it easier to fit. So pop the nuts on first, then the olive, and then we just need to screw that into place, and obviously tighten it up with a spanner. Okay, so that's the first end done. Had to slightly bend the coils out in order to get that on there, so it's not quite as pretty as it was at first, but it will still do the job. So let's do the other side now. So there we have it. Getting these T-pieces on was definitely the most tricky part so far. It was very close to putting in some pretty nasty kinks into the pipe there with the bends I had to put on, so that end ended up a little bit of a mess, but overall it's still pretty neat and compact. Got the little feet on the bottom there, and yeah, it fits nicely into the pot, sat horizontally like that. So just need to put the inlet and outlet pipes on at either end. We'll probably bend those in towards the middle slightly so they come together at the top, and then just need to fit the hose adapters on, and that should be nice and easy. Famous last words. So there we've got our inlet and outlet pipes attached on, so we need to bend the tops over where it will go over the top of the pot, and put the hose adapters on. Might Jubilee clip those together or something just to make it a bit more stable, but I might not, we'll see. Okay, so I've sat it in the pot, so I've got a guide now for where I want to bend the two pipes over before I fit the hose adapters on. So put that right over the edge. Doesn't really need to hold the weight of the chiller because it's just sat on the bottom, but I just want to make sure that the hose adapters are right over the edge and away from the side of the pan, because quite often they are the weak link in terms of getting leaks and drips. There we go, nice neat job. now we just need to fit the 15 to 8 millimeter couplers on there, the ends of which fit perfectly onto the 15mm adapters that you get with these push fit hose fittings. So just with these 8 to 15 couplers on the 15mm end, you obviously don't need the olive and the nut, so those can be got rid of. The fitting to the tap, they normally have a little adapter that will go in. This one's actually got 2 adapters. They do have washers in them which should seal it to an extent, but I've always found they do tend to drip a little bit. They're not the best seal, so it's worthwhile putting a little bit of PTFE tape on the threads here just to stop that from dripping, otherwise you can end up with quite a lot of water going everywhere during the course of chilling down your wort. So once I've done that and then got those fittings on the end, it's pretty much done and we can do a leak test on it. So there we have it, the finished article. Few bits of slightly dodgy pipe bending on there, but on the whole I'm pretty chuffed with that. As I said, the hardest part was just getting these T-pieces on, getting the pipes to bend round without kinking them. Ready to give that a leak test now. Okay, so I've got some water running through that now to test it out. All the joints seem to be dry at the moment, which is good, and also getting a pretty good flow rate through that as well. So I was expecting it maybe to be a little bit slower with the 8mm pipe, but I'm pretty pleased with that. That should work quite well. Okay, so this is the test run for the chiller. We've got 23 litre batch of Pilsner in there, just come off the boil as you can see, and I'm going to put this timer on here. Usually, well, with the previous chiller, it takes about 20 to 25 minutes to chill this amount down to pitching temp, so we'll see how quickly this goes. Okay, so that's just over 10 minutes. We are at what would normally be pitching temperature, so 20 degrees. I will take this one a little bit lower because it's a lager, but in terms of comparing it to the previous chiller, that's the same sort of temperature. And there you go, stop clock, literally just gone over 10 minutes. So that's at least halved the amount of time it takes to cool a 23 litre batch down, so I'm pretty happy with that. In fact, I'm really happy with that. It's yeah, chilled that down rapidly. Obviously with a lot of vigorous stirring as well, that's helped. Probably going to be looking into fitting a whirlpool onto the pot just to mean I don't have to work quite so hard to get it chilled down, but yeah, that worked really well, so pretty impressed with that.
I'm the dude, so that's what you call me, you know, that or his dudeness or duder or, you know, El Duderino.